Greetings and welcome to the ALPINE AgroBite Phosphorus presentation at the Canadian Spud Conference. Potato producers continually strive to meet the demands of the processing companies as well as our consumers. These demands include tuber quality, a greater storage potential, and the benefits of increased marketable yields created within our total yields. It is also important to note that sustainability will continue to be at the forefront as we meet the demands of our consumers. As plants are composed of over 93 to 95% oxygen, carbon, and hydrogen, it is by giving attention to the other elements that we can manage increased quality and yield. During this presentation, we will discuss the nutrient requirements to produce potatoes with a particular focus on phosphorus. With so many different application options, we will share how ALPINE supports growers in meeting the maximum yield and quality potential. The key to potato fertility is a balanced fertility, allowing us to avoid nutrient deficiencies as well as antagonism in the soil and in the potato plant and tuber itself. As you see, potatoes have a very high demand for potassium, but while we always look at the minimums, we must also balance so we do not create deficiencies by over-applying. There are laws of maximums that can cause us as much grief. It is balanced fertility that creates nutrient use efficiency across the board. The role of phosphorus in potato plants does not differ from any other plants when it comes to energy production. In potatoes, it is part of tuber set and numbers, root development and cell division, starch synthesis, increased leaf area and canopy development, component of phospholipids and phosphoproteins, cellular energy, driving plant growth and development, and it improves specific gravity and tubers. And as we can see in the graph here, you notice that as the nitrogen goes up, specific gravity stays or drops a little bit. But as we increase the phosphorus levels, we'll see that actually the specific gravity continues to increase. Phosphorus also has the highest removal rate of all nutrients when growing potatoes, even though it may not be the highest demand rate. You can see here where actually it has a 65 pounds per acre uptake, but the removal is still 45. It's 69, almost 70% removal rate. So there's a lot of phosphorus that leaves with the potato plants as they're harvested. As we know the importance of potatoes across the globe, as well as the attention now paid to phosphorus use efficiency, we must continue to adopt our fertilizer management, especially when it comes to potatoes. Understanding a potato's root structure, we must continue to develop strategies to maintain and improve our application rates and timings. Looking at the root density of potatoes compared to sugar beets and to wheat, we see from the diagrams on the right that potatoes only have 25% of the root mass of wheat. This is a challenge because fibrous roots are essential for the uptake of phosphorus. We can then couple the lower root mass with the limited movement of phosphorus in the soil. And as you look to the chart to the left, you see that the phosphorus itself does not move very much into the soil compared to nitrogen and potassium. And with roots only being able to draw nutrients within 2 to 3 millimeters, we have to have the phosphorus in close proximity of the roots for it to be taken up. We must also understand other limitations that restrict phosphorus uptake and availability, such as temperatures and moistures. And as you can see in the graph here, that it actually, when temperatures drop from 21 to 13 degrees, that the percentage of P uptake is dropped by 70%. Zinc will drop by almost 87%, and potassium can drop by 48%. So when we're planting into cold soils, we end up having issues with uptake as well. There are many factors that limit how quickly we can get phosphorus into solution and then back into the plant. This is where the ALPINE orthophosphate starters enhance phosphorus uptake and early vigor. As you see here, we can actually be tied up with calcium, aluminum, and also with iron. While utilizing our soil and tissue samples to again create balanced fertilizer plants, we must always consider our pH as well as iron, aluminum, and calcium. And we know that phosphorus is most available when we're in that neutral range, or that 6.5 to 7 range. But our levels of aluminum and calcium can really bind and keep our phosphorus from being available to the plants in the soil solution. We also know that forms are important. When it comes to plants, they are able to take up phosphorus in the orthophosphate form. When it's applied in the polyphosphate form, we look at temperatures and soil moisture, and it could take days to weeks to be able to turn that polyphosphate into a usable form. So when we're looking at planting in colder seasons, it becomes key that we have orthophosphate available to the plants. We've also learned that different varieties also respond to how they take up phosphorus. As you notice here, these are 3 varieties of a trial that was done in South Africa, and each variety takes phosphorus up at different ranges. But as we increase from the 100% ortho and actually we drop down to the poly, we'll see that we have some consistent drops as far as what it takes. I know that if the potato had a chance to actually order its own fertilizer, it would probably be ortho. When looking at phosphorus levels within the potato plant, it is key that we maintain a minimum tissue level in the 0.22 or 0.22 soluble levels throughout the season. And this is where foliar applications can really pay off as we monitor, keep that in the range, because it's important that we have the potassium and phosphorus available to the plant as we need it. And studies have shown that if we can keep that in that range, that we get better crop health and better crop quality. We must also consider the right time to apply and how our applications match up with potato uptake. With limited uptake, we look at foliar advantages and the value the potato plant can utilize the phosphorus that we've applied. From this 2003 to 2006 data, we see a 25 to 35% increase in phosphorus uptake when banded, especially when planting into cooler soil temperatures. And we will show an even better phosphorus use efficiency when adding an in-furrow relay, when we actually have in-furrow, which will help synergize our banded and 2x2 applications. A third advantage is the value-added potassium fertilizer advantage. Here we see the increased phosphorus uptake in wheat by almost 11% and corn by 6%. This will be discussed in our second section when we talk about the ALPINE K-Tech strategies as well. But it's neat to know that when the potassium is in play, phosphorus becomes more efficient to the plant. As ALPINE has been long known as a starter fertilizer company, we continue to see how we can create phosphorus use efficiencies through humic and fulvic acids and other biostimulants as well. Here we see an average advantage of 32 hundredweight with the Snowdens, as well as another gain of 21.6 with the russets. By adding the humics and fulvics, we're finding that we get much better usability of the phosphorus uptake, as well as microbiology in the soil. Quality. In this trial, we replaced 8 gallons of the polyphosphate, the 1034O, with Alpine Starter, and we added in furrow. This increased both the phosphorus use efficiency, which it correlated to yield. We then took it a step further by adding another 2 gallons of our K24, which is our potassium. So if you notice into the third application, it was 12 gallons of 1034O. We actually put down 6 gallons of our Alpine Starter in furrow orthophosphate and added another 2 gallons of potassium acetate. And then the synergy between those is what caused us to not only get potassium use efficiency, but we were getting continuous, constant gain in yield as well. This planned approach, utilizing staged foliar applications, delivers the highest efficiency of nutrients and in turn creates the highest return on the investment on the grower's crop nutrient program. As we see in the chart from the University of California, Davis, there is a key benefit to include phosphorus into your foliar plan. The numbers here show nitrogen, 1 pound for foliars compared to 4 in the soil. And even this number seems extreme, which is 1 to 20, we know that there's a very good benefit to be able to maintain and keep your petal levels at that 0.22% for increased health and energy. On this slide here, we see that the foliar application of phosphorus increased from 20 to 40 pounds, and so the yield follows. Again, we must look at the limited root activity that potatoes have, knowing that by having phosphorus into the through the stomata and into the plant, it encourages to drive energy and use all the other nutrients more efficiently. With 3 foliar applications of ALPINE G22 or G240S orthophosphate, both with and without ALPINE K-Tech, we see another advantage as well. And here along the bottom, you see as the potassium acetate was included, the rate of the yields continued to increase, as did quality done at the Michigan University. With the yield advantages, we must still take that to a saleable product. 3 years of data from Wisconsin supported in-furrow yield and quality have shown a better fry with less sugar tips for increased consumer sales and quality. And as we've added the potassium into that third plate there, you will see again, there are less sugar tips when you take a close look at how they're fried. Well, as we wrap up this presentation, I would like to thank you for allowing me to share some of the ALPINE phosphorus benefits. And you won't want to miss the ALPINE AgriBite K-Tech acetate experience in our next section. Please join and take a look at our potassium acetate. So I'd like to thank you and trust you have a healthy and prosperous 2020 in your potato growing season. Thanks again and have a wonderful day.